Okay, so looks like I'm live here. Right, just okay. So YouTube is not receiving enough video. Okay. Hello, folks. How's my audio? Okay, how's so video looks like I'm live here. Right, just okay. So YouTube is not receiving enough video. Okay. Hello, folks. How's my audio? Okay, how's so video looks like I'm live here. Right, just feedback. Okay, so let's begin this. To know how many, just 2 people are on the stream, right? Can you see this? Can you see the chat window? What's happened? Stream settings. Enable. Is chat up there or not? That's just me. Can you hear me? Oh boy, it's like no feedback. Okay, so just a minute, folks. Just a couple of starting issues. Yeah, maybe a few minutes. Maybe you could grab a drink or something. And looks like it's fine. I just want to see if there's any chat showing up. And if it does, then yeah. Okay. Just a minute, folks. Just a couple of alright, that's good. Issues. Yeah. Maybe a few minutes. Maybe you could grab a drink or something. And looks like it's fine. I just want to see if there's any chat showing up. Okay, there is chat showing up. Okay, so righty, so right, I don't need this anymore. Okay. Okay, so that's good. Alright, so let's do this. Okay. Fine, so okay, so so okay, 3, 2, 1, go. Alright, so good evening, folks. My name is Jagannathan Sampath. I'm calling you tonight from India, Chennai, India. And this is a sort of lecture for you know, the Music Academy in Krakow, and you know, kindly organized by Professor Marek Koloniewski. And the title of the lecture, I just made it up at the last minute, so it's called Virtual Structures and Automatons, yeah, for Indiscriminate Sound. Okay, so that's like, I mean, normally, like, my friend in England, he's Tom Webster, he says, Jag, you're very sort of anti-academic, and you cannot give a presentation at Music Academy, so make your title really good. So there you go. That is good title. But then once I did the title, I realized that there is a lot of truth in that. It kind of gives me the about what my work has been over the years. Like I've been working on this, and for is it sending anything? Okay, so I think it's just buffering and unbuffering. I hope this is good enough. Okay, so I've been working on my software called Dennis Noise for the last 14 years. I've told you about this in the concert as well, when I was supposed to play. And yeah, so the main idea is in this title, virtual structures and automatons for indiscriminate sound. Okay, so virtual structures. In a structure, what is this thing called structure? So structure, you could think of it as like a physical structure, like a house or like a car or a build, like anything that's solid, and anything that you could handle with your hands or kick like a ball. All these are structures. Normally you find that these structures are, they have certain rules, and they interact with the environment. Okay, so so like for example, a ball, it's influenced by gravity, and it's engineered in such a way that it has a bladder inside. You fill it up with air and so on. So it has its rules, right? So if there's no air, you can't kick the ball, and so on and so forth. So that's a structure, right? And virtual structure. So when we talk about virtual, what is virtual? Virtual is something that actually doesn't exist, right, in reality. So what could be virtual? Like all of mathematics, you could say, is virtual, because you're always, creating things, structures in your imagination, right? So you could say imaginary structures are virtual structures, right? So a theorem like a Pythagoras theorem is a virtual structure, right? It has its application with reality in the sense that it interacts with reality, but it's still a virtual structure. All of mathematics, you could say that. Now software is also like that. Software, pure software, if it's not interacting very much with the world, right? I mean, the only way you interact with software is through the input devices, and the way it interacts with you is through the output device, which is the screen, projector, and so on and so forth, right? Televisions, screens, yeah. And the input devices are very many. Like you have the mouse and the keyboard is your fundamental input devices, and then you have other many input devices. In music, for example, you have the MIDI keyboard and many other devices, that make music possible in the digital space. But we'll come to that later. So, when I say that software is like a virtual structure, we're talking about something which is totally not real, in the sense that it's virtual, right? But is it? But could I say that it's just mathematical? No, software is not mathematical. It uses maths, some kind of, it uses maths, but it's not mathematical, because, and because the computer actually, it doesn't have any sort of, it doesn't put any limits, in the sense that it doesn't ask you to do maths, for example. Right, so software is not mathematics. Software, like I said at the preliminary for the concert, it's its own medium, yeah. And so my interest has always been, exploring these virtual structures. Like, yes, you need to use maths to create any virtual structure, like rules basically. You don't even, not even maths, like you could say if something goes beyond this point, do that, something goes below this point, do this, and so on. So that itself, so structure is, you could say, a collection of rules, right? And maths is a way to I don't know, like, you know, create rules and investigate whether those rules are valid, you know, in whatever input and so on that we get, and so on and so forth. Like you can prove things and so on. So virtual structures there. So in software, it's like we are creating these you know, virtual structures, right? So it's a virtual structure, right? So it's hard to talk to people when you can't see them, you know. So I'm kind of struggling a bit, but hey, I actually prepared, so I'm not going to struggle for too long, right? Okay, so as I said, you know, the structure part is this, right? So you have, it's totally virtual. There's nothing equivalent to it in the real world, right? That is what interests me, right? I want to create things inside the computer which have no or very little parallel with what's going on in the real world, because, you know, software has always been a field where we've been trying to solve other people's problems, you know, including you know, in our case, musicians, right? So but for me, I'm interested in software on its own terms, right? And of course I'm interested in music, you know, sound and so on, but I'm not confident enough to be like a musician, like somebody that plays the flute or the violin, or there's a lot of weight of tradition, you know, like a lot of weight of tradition. I mean, how am I ever gonna, you know, be a better violinist or something like that? It just doesn't cross my mind. Nor can I be like a better mathematician than, say, you know, anyone that's out there. Like I don't consider myself really a good mathematician, for that matter. You know, like maybe I'm just good in the sense of understanding the maths, but you know, anyway. So what I'm trying to say is that it's like, what's my job in this, you know, like where do I fit in, you know, where do I fit in? So that is one of the questions constantly for anyone that has this urge to do something creative, right? So so I'm like, I mean, I somehow kind of, you know, you could say that the moment I saw the computer and software, there's always been this sort of addiction really to make stuff, to actually create new stuff and to see what the computer will do, you know, and then when it responds to you, then you're like, oh, okay, so maybe I can do this, and then see what it does in return, right? So this sort of a ping pong, this kind of back and forth thing is very powerful in computing, which is very unique, really. Like in a sense, it's like playing a musical instrument. So in the sense that the computer becomes a musical instrument, but then, you know, the computer is like an omni-purpose device that people underestimate it, in the sense that people don't really see it as a musical instrument. People want to get away from the computer, right? They want to say, I don't want to do music on the computer. Right? I just use it because I have to use it. I need multiple tracks to record my songs and then mix them all together and then make a track and so on, right? So they're always using the computer for their purpose, you know, like they have an ideology, they have a need, and then they use the computer for that purpose. I have no, you know, no such need. Like I'm not out here to create music. I'm not out here to perform in big concert halls or something like that, right? So I'm really interested in like this original thing. Like when I was a kid and saw the computer for the first time, like you could write, you know, like try to draw a circle, you know. And the computer would draw a circle like one point at a time, and you're like, oh my god, this is so good, it just did what I wanted it to do, right? And let's say, and normally it's not that sort of an aha moment, like straight away, like it's probably not doing what you wanted to do, but you're happy that you at least got a point on the screen, you know, like, you know, you'd be like close to the screen like this, and and you'll be like looking for that point, and that point is, oh my god, that point is there, you know. So you get very excited with that, right? So, and for me, the same thing happened in sound. Like, you know, like I got into graphics because we, you know, in school we draw the circle, draw the lines, and so on, triangles, polygons, pentagons, this and that. And then after many years, like you know, after I was in the visual effects industry here in, you know, local, you know, we have Bollywood here. And I was working for, you know, post-production houses here in Chennai, which it's a very very important post-production center for Bollywood movies, as well as our own local film industry and almost all of South Indian film industry. A lot of the post-production is done here. Maybe things have changed now, but when I kind of started it, this was a major production center. I think it still is. Anyhow, so then I did special effects programming for movies using C++ language, C language, and on Silicon Graphics workstations. And then I kind of moved to England and worked for a computer games company. I was there in England for many years, you know, and then now I'm back in India, and then Corona and lockdown and all that. And that's the human part of the story, right? You know, let's wipe that clean, right? So basically, what we yeah, like. So I matured in graphics because of that trajectory. First you want to start drawing something on the screen, and then you're like excited, and then like, what can I draw more? Now I want to be able to draw interactively. Like I want to be able to choose if I want to draw a circle with a particular radius, with the, you know, all these things. So you see, software is very much like that. It's like creating a painting. So like you start with one thing, you're successful, then you're like, okay, I put that another color there, and then you're like, there. You know, with software you could undo. You know, you could just save, or, you know, whatever. You know all this, right? So that's the power of software, right? And which is used by, you know, that's what you see, right? You know, nobody puts together a track in one take. Nobody releases a track in one take, right? I mean, they just make hundreds of takes. I've been to audio studios where they do recordings, and they take hundreds of takes and splice them all together, right? This happened way back, right? Even during the analog days. You know, an album like Miles Davis' Silent Way is just you know, like a put together thing, because if you listen to the entire sessions of Miles Davis, you really know that, you know, in the album called In the Silent Way, right? You know that they probably played 6 hours or something, and the CD is maybe 1 hour, which is like 1/6 is good. So it itself is very good, I guess. But anyhow, so what I'm trying to say is, in software you could create these virtual structures, right? These pure ideas. You can express ideas. If you want to express mathematical ideas, you can convert the mathematical ideas into software rules, right? And then make the computer do it. Okay, so it's like, in that sense, it's like a slave, right? But then when it doesn't do it, it actually makes you a slave, right? So it's like this whole thing. I mean, I'm a junkie for the computing, right? There you go. So so computing is really cool. But when I wanted to do computer sound, already there was a lot of weight of tradition again. And there was a certain way of doing things in computer sound. Like they just want to kind of, you have these analog synthesizers, right? I mean, analog synthesizers, very expensive things. I mean, when I was growing up in India, like there was hardly any sound synthesis or sound experimenters. There was maybe, but too far away, the country's too big, and I wasn't interested in sound at that point. So I was more interested in graphics, and as I told you, the industry was there to support my interest with some employment, right? Anyhow, so here, the weight of tradition in sound, in sound synthesis, electronic music is very heavy. But what I just ignored it, in the sense that I just ignored it because I wanted to get, that pixel on the screen, that audio, like a pitch on the screen. And the first time I coded it was like, whoa. It was just a normal sine sound, like just that. But it was really exciting because it's like, actually we coded it. We actually coded it, and it's a bit like making somebody, that was blind see. It's almost like that. I can't, maybe it's too much. Maybe that, it's not that great, but it's almost like that, because I was running around, the room I was in, I was shouting and screaming when I got the first sine tone, because that was a step up for me, because now all of the code that I do, right, can be actually come out of the screen. This is very important, to come out of the screen and into the real world, right? With the speakers, I'm moving the air and I'm making the sound that you can hear. And yeah, so this was really important for me. Yeah, this was a very important moment. So then I was, like I said, because in visual effects, like the software that does visual effects, like 3D or 2D software, is very, very mature and very mathematically quite sophisticated, right? Sound software is also like that, but if you take C Sound or any of them, like Max MSP or Pure Data or Super Collider or Ableton Live, anything that's out there, it's quite mathematically sophisticated. But some of the mathematics I was interested in, they don't seem to have it like widely used. There was one or two researchers who had done some introductory work with Bezier curves into waveforms, but Bezier curves is used everywhere in computer animation for moving a character from one point to another, like or a part of a character from one point to another, and extend other things like particles and so on, particle effects, smoke, all these kinds of effects are all possible in the visual effects industry, but none of it was like seen in audio. It's like I couldn't understand, why is it that there's no equivalent in audio, or at least it's not in mainstream audio, right? Even today, I mean, DIN has some good tools in terms of geometric and sound and geometry to sound and so on, but as I told you, like when I started, there was nothing in front of me, right? So the good software was Reactor and things like that. But anyway, that's my water. Some drink. Yeah. Okay, so are you all listening? Yeah, it's still live. Oh my God, don't know what's going on the other side. Okay, so let me just check, how am I doing with the professor, because if they think that I'm just waffling on and on and on, I mean, this may be not a good thing. Oh, I could just check my stream. Can I? No. Anyway, okay, I'll keep going. Yeah, I'll just keep going. Okay, because I need to load that, this and that. Oh, yeah, I'll just keep going. So virtual structure, that's a mosquito, right? There's so many mosquitoes here. Got this mosquito bat. Anyway, so what I'm trying to say is virtual structures, right? And so the first step in DIN was to, once I got the tone, and then it was like, okay, so you have sine, and then I could very quickly put a sawtooth curve. Initially I started out with the sine, programmed a sine wave, yeah, and then a sawtooth, and then the triangle wave, and so on. And then it's very clear to me that what actually, this is what the visual effects industry has totally solved it. Solved it means like bet it to death, it's like completely solved it, which is like, how do you move from one point to another, right? So what's happening when you're doing sound is that you're always moving from one point to another. The way you can imagine the waveform as a point moving from silence to maximum to silence, and then maybe the negative -1 maximum, and then back to silence, and so on. So it goes like that, right? So it's always a point moving from one position to another, to another, and so on. So, and the very general purpose way of doing it is with a Bezier curve. Why? Because you have enormous control. Like you can really, especially this is very important in animation, because you really want the character or even NPC, like non-playing, characters, like objects or whatever, things flying around. Of course, you can do that with physics, virtual physics, virtual again, virtual structures there. So, but with Bezier curves, you can actually totally sculpt the shape of how the point is going to move, right? And for me, it was like, this must be done in audio. Like, this must be done in, I expected everyone to be doing this, right? And there was nothing. It was just one researcher in University of Wessex. His name is Nick Collins, right? And I think he'll be really happy to know that I acknowledged him, because he's an academic kind of guy, right? Anyway, so yeah, Nick Collins, mate, you did it first, all right? Take it from me, you did it first, but you didn't do enough. Oh, you kind of did enough, or did the basics, let's put it that way, right? But what you'll see in DIN is somewhere else right now. When I met Nick Collins, he was quite appreciative after a while, right? So yeah, this is why I'm kind of anti-academic, like this is why I don't publish so much. Tom Webster says, you don't publish so much, Jag. Yeah, because there you go. So anyhow, so you have this sort of thing where you're able to sculpt really well. So what happens when you sculpt? This is the thing. So when you send a sine wave, every waveform is basically how the loudspeaker is vibrating. You can't see it because it vibrates too fast, right? But when you sculpt the shape, you can actually make the loudspeaker really dance, and the effect is you're gonna hear that as a difference in color and sound, right? What we call timbre, right? So you can, it's that's the thing in this. Like, by sculpting the shape of the waveform, you're able to change the harmonics, change the color of the sound, and if you can do it all real time, because we can do it, if you can do it all in real time, then it's a lot of fun. This is what I wanted to do. So I stopped everything I was doing in real life to really focus on this. And that was the first part, to put the Bezier curve in and have, the advantage of Bezier curve, you can see it on my website, is that you can create all these waveforms. You can create the sine, you can approximate the sine very, very close. Not exactly the sine, because sine is its own function, right? But you can approximate the sine, very, very close, right? And then you can get very easily sawtooth, very easily triangle waves, very easy, all the linear waveforms, the pulse, square wave, all that, which only 4 is used. Why is only 4 used in software? Because the analog weight, the weight of analog, everyone is like, they want to, this is the curse of computing. Like, whatever they see on the analog, they want to replace it with digital. I don't give a damn about that. Right? I'm not interested in that. I am a computer programmer. I didn't grow up with analog. I didn't have a studio at my disposal, millions of dollars anyway, right? And you'll see, like, the moment hardware was commoditized, that is when people started becoming freer. Like, you could, once you could do it on the PC, then things change. Otherwise, because I know in the film industry, like, you had Silicon Graphics workstation, they would cost a ton, man. Like, really a lot of money. Like, we had to sign logbooks to work on a Octane machine, Silicon Graphics Octane, or even go and scan a negative on the film scan or something like that. It was very expensive, very expensive. And then the PC came along, we know all that. But what I'm trying to say is that once I got the Bezier curve going, it's like I had this single tone, right? But in Bezier, and it's like, okay, it's changing, the timbre is changing and everything, but it's still, you need more, right? That's the thing with software, you need more and more and more and more and more, right? That's when software becomes totally bloatware, and then it kind of gets really big. But so I just wanted more, in the sense that, okay, now I got the basic tone, which is at a particular hertz. Now I'm like, okay, what did we learn about music in school? So we learned like the note and the octave, and then the fifth and fourth and so on. So these sort of things are there, and then you start to put them together, right? And then you're able to make these pitches and stuff, right? And then you want to, like, you're thinking, but the computer can make any pitch, like in between pitches. So what should I do? Like, okay, so then I created this structure called the Microtonal Keyboard. But what I want to do is, I don't want to go chronological, right? Let me just switch to din, because you've seen enough of my ugly face, right? I just want to kind of, hope I can, okay, I can maybe reduce this size a little bit and go into the corner. Can I do that? Okay, no, wait. Composite video capture device. Okay, so that I'm going to reduce. Oh yeah, beautiful. So I'm going into the corner. So I'll take like a 1 minute break just to see, you know, how am I doing with my folks back in Poland, and just check, just do a temperature check, really, to see, if I'm, if people are happy with me or not, so let's see. So I might, only my audio may be active right now. I'm trying to get to my stream page, which is kind of, I've been given 1.5 hours to talk, so already I'm half hour inside, I think. And so I'm going into the YouTube page, and I'm given 1.5 hours. I should have warned you about this. Sorry about that. I just didn't. So, but all of this is anyway recorded on YouTube's infinite discs. So, so you're gonna, you're gonna see this. Oh, looks like my stream is fine. So it says there are live viewers. 8 people are watching this. Oh my god. Okay, view in the live control room. Okay, so I have the control room. Imagine this, YouTube is giving me a control room. Okay, so I'm now trying to get into the control room and take a temperature check of how am I doing, maybe some feedback. And oh man, already I have like I have people who are like not quite okay, so calculus is not applied enough to the, okay, this is kind of before computer math shapes were drawn on paper, every process the algorithm. Yeah, we'll get to that. Thank you. First of all, I'm glad that you guys are still around. Thank you. Came here for a check, health check, stream health check. Okay, so all right. Okay, all right, great. So the folks are listening. All right, so nobody is upset with me, so that's good. That's good news. So I'm gonna kind of move away from this window then, because it looks like everything is good. YouTube is telling me that everything is good as well. So yeah, it says good connection. All right, so I'm gonna close this window again then, and come back to the video and really get into din, really, because that's what you guys want to see. But the ideology is all well and good, but but the ideology is important as well, because now is my chance to really lay the case for software, for pure software sound, right? So that's the thing. Okay, so so come back here, all right, and go back here. All right. Okay. So maybe a little bit more. Yeah. I'm addicted to this. All right. So so I don't want to go chronological, right? So what I'm going to do is I'm going to again, minimize myself. I'm happy that people are still up there watching. Maybe I'll keep myself that big. No, that big is enough, right? Yeah, that big, just above Mondrian, right? This is called Mondrian, right? So first what I'll do is the reason I'm starting non-chronologically is because Mondrian was created this is my software. It's called Dinner's Noise, and there are many instruments in Dinner's Noise, and one of these instruments is called Mondrian, right, which is what you're seeing right now. And Mondrian was the name of the instrument is inspired by the Dutch artist Pierre Mondrian, right? And I created this instrument in Poland. So in a way, kind of want to tribute my my guardian angels of Poland, right? There are many guardian angels I met in Poland. One is, of course, the professor. I have other. I want to thank Marek. I can't pronounce his second name. Sorry, Marek. But he came at 3 in the morning because the professor asked me to pick me up from the Krakow bus stop. Right when I came from Berlin to Krakow, 3 in the morning, because the cheap bus, Polski bus. I hope they're still running. 3 in the morning, he dropped me off at Krakow, and this guy came and he picked me up, and it's amazing. There's a 24-hour tram service in Krakow, so it's all wonderful. So you can still travel. The city is quite small in the sense that I guess 700, 800,000 people, maybe a million now. I don't know. Maybe they're very big now. I don't think they could have added 200,000 people in 3 years now. And I don't think, Polish people have other entertainment. All right, so that's a poor joke. Okay, had to sneak one in. All right, okay, so what am I trying to say? Right, so Mondrian was created in Poland, or at least the initial core idea. It's like, how did it happen? Okay, so I was in this shared house with many artists and very activist type of people, and I was there, and I still remember this because we were in the kitchen, and there was this friend, there was Justina, and then there was Natalia, there was Silvek, all of them, we were all sitting there and talking, and on the table I was there, and sometimes they would talk things in Polish, and so those interludes, when they're not talking in English, I can understand that. I'm not I'm quite used to that, sometimes the jokes don't translate well into English, right? So sometimes, anyway. So I had my notebook, and I was just doodling, and I was doodling in the sense I would draw a line and then split that line, and then split that line and split that line and split that line and split that line, split that line, and so on and so forth, right? And then when I was doing this, like when I was doing a very intense kind of drawing, eventually I realized that this looks a bit like a Mondrian sketch if you make it this way, make it rectangular and so on and so forth, like it looks like that. And then I went and saw like how Mondrian developed his art, and it was pretty much he did that by initially he was drawing trees, and then those tree branches kind of became more and more rectangular and occupy space, and they became the final abstraction that Mondrian is very famous for. So in the sense that I started similarly, like how you would just draw a line, which you could think of it as the trunk of a tree, it's coming out, and then subdividing, which is the branches, which is pretty kind of normal for us computer programmers, because we always have various data structures which were like binary trees and so on, and so we do that sort of thing. So or the folder hierarchy, for example, in software you have the folder, the root folder, from there you have 3 folders, and then from in that folder you have 2 more, and then in that 2 more, and so on and so forth, right? So you have all this. So that is one part of it. And then Mondrian is in a different sense, but interesting that he drew trees and then it converted into that. And trees are interesting themselves, as you know, because what they do is by subdividing branches, they are actually taking over the 3D space as much as they can, right? Effectively, they kind of, under the ground, the root system is also going this way, and then the leaves are going this way. So you have this whole spherical thing, and they are taking over the 3D space, basically, right, as much as possible. And Mondrian, by subdividing, he's actually subdividing the plane, and he's taking over the plane, right? So that is the thing with Mondrian. So I just want to show you very quickly this video. I hope it can come up. Okay, so wait, I can turn this off, maybe. No. Oh, I need to bring this to this window, I think. One second. Give me a second. So let me just let me just move that into this workspace, and now, whoa. just a minute. Okay, so yeah, you can see me. You can see that now, right? Maybe you can't see me anymore. Is that important to see me? It's not important to see me. You can hear me at least. Okay, now we just want to first of all play this video for you just to show you like what's going on in Mondrian, right? So let's play that video. So you can see how the trees are transforming, right? Slowly turning into abstraction, right? There are many videos like this, and this was a short and sweet one I picked for tonight. So doesn't come to his final painting. I hope it does, but we'll see. Yeah, I think it should. So you see how the trees, the branches, subdivision of the plane itself, right? There you go. See, that kind of, he moves away into this, right? Right, so there you go. That's it, right? The end. All right, great. So, wait. Okay, what is this? All right, okay. This is OBS. Okay, I can close that. All right, I'm back there. All right, that's beautiful. That's nice. Oh man, OBS is lovely software. Maybe I should donate some money to it. And yeah, it's very nice. Okay, so let's keep going, right? So that is one of you saw. So that is and the same thing I got here pretty much. So you have the initial blank canvas here, and wait, let me get to the. Okay, so I need to push this as well. Sorry for this mess, but. Okay, so this guy goes to the next workspace. All right, because it likes. So I guess you can now see my mouse cursor. All right, excellent. So now I can minimize my OBS, and hopefully it will take my video camera and everything. All right, so I can minimize this guy. I can just a minute. Video capture, composite tools off. Okay, great. So I can minimize this, and hopefully you can see this. So this is this is what is called Mondrian, right? So what's happening here is that initially you have this canvas, right? And this canvas. So this is something I kind of how to say, like arrived at the design. It all came to me, right? So it's just the thing. When you're in the zone, in the right space or the zone, it just comes to you. You don't have to, and you know that it needs to be done because it's just coming to you. So why not do it? It's not forced. Nobody's asking you to do it. So it's just you're there. It came to you, and you're putting it out. That's it. So anyway, that's enough of that ideology. But so. What I thought was, okay, so I have this blank canvas, so why not bounce a ball, which is pretty much like this. You have this breakout games like we grew up with, so this bouncing a ball thing in a rectangle, when the moment we see a rectangle, we want to bounce a ball in it, So that was the bouncing the ball thing. So you could just go to tools and add a bouncer. So I could click drag and release to launch a bouncer. So you could do that. Escape to stop. Right? I'm going to reduce the octave. Right? Let me just check if I got the sound right. Just give me 1 second. So let me just see if I got the sound right. Okay, so it looks like the sound is coming through. So that's all good. And yeah, the sound is good. All right, so back to tin. All right. So what's happening is that right now I've paused the ball. Okay. Again. So this whole canvas right now is, you could say, it's a virtual structure. It's got no there's no real canvas. I'm not even saying it's a canvas. I'm not making it look like a canvas. I mean, if this was a VST, then people would expect me to make it look like a canvas, right? But it's not. It's got this sort of randomly generated color, which happens to be this nice lovely violet or something, and then you have this ball, which is not really a ball. It's actually a small box with a small pointer, you could think of it as the nose, and then it has a trail, right? So all of these are virtual structures, maybe in the sense that you can allude to it as a ball, because it's bouncing, but it's all abstract, you see. Like this is not a ball, and it's bouncing inside a box, which is not really a box, not also a canvas, and so on and so forth. So this whole thing is a virtual structure, all right? And we have layers of rules in virtual structure. So at one level we have this, at another level we have, okay, so what should I do when the ball hits the wall or the ceiling? So then I thought, okay, straightforward, trigger a note, which a lot of instruments do things like that. So something hits something, they trigger a note, all right? And this is a very piano metaphor, right? So I've got nothing against the piano, but in the sense that I'm tired of that metaphor, but in the sense that I use it here, right? But the idea is that piano is a percussive instrument. So you hit it and something, a sound comes out, right? And this sound is percussive in the sense, it is tonal, but it is percussive, right? Is the user interface of the instrument, you could say, is percussive, right? And so okay, so you hit a wall, trigger a note. Okay, so what note should I trigger? Now that is an interesting question, right? So as I said, like I could trigger like just the notes, but then I thought, oh well, that is fine, but the computer can once again play any note, right? So you're like, okay, why can't I trigger any note? So in this sense, you have this sort of when it hits here, it will play the C octave above. When it hits here, the play C, the middle C, and then this middle C above, and middle C here, and middle C here as well. So it's better to kind of show it to you. You see, so it's like so right now it's playing. This is middle C. That was middle C and octave up middle C. Maybe I can turn the I can turn the frequency display on, right? So you see that's middle C, and the volume drops, right? So now you have this visualization of it, of the note that's been triggered, and the radius of the circle that you see is going to be the volume of the note, all right? So there you go. So I can octave shift, right? So it's like this. So I've shifted the octave way down. So the interesting thing is now, okay, Mondrian subdivided this plane, so let's subdivide it. So let's say I put a subdivision there, right? So you can figure out how to use the software through my other videos. I just want to show you the concepts tonight, all right? So just to inspire you to perhaps check them out, download an eval version and check it out, or if you're on Linux, you could download the whole thing and build it yourself and play. All right, so anyway, so this is and now what it will do is when it hits this wall, it will play the note G. All right, so it will play the note G, and if it hits this wall, right, this ceiling, it will play the note B flat. So this sort of, you have to get used to this sort of orientation. So the ceiling is on this axis, and the ceiling is on this axis, the x-axis, the horizontal axis, and the wall is on the vertical axis. So the note that will be triggered is based on whether you're hitting the wall or the ceiling. All right, so there you go. Yeah. So now you can delete that, you can delete this like this, and then maybe put it back on, right? So let's say I'm going to put it back on. Now you see that you can actually subdivide it here, anywhere, right? So that is the thing that is again the rule of the virtual structure. What sort of rules are we putting into practice? you know, what are the rules of the game. So it's basically a game, right? So you can keep it here, right? Yeah. Okay, so, or I could actually move this around dynamically, right? So that can create interesting things. So I'll show you that next. So there you go. So interesting, right? You see that? So the moment, you know, one of the things Joyce is to create these rules and explore the rules. That's what the computer is so good for. You know, like somebody said on the chat about the maths, you're doing pencil and paper. When you're doing that, what happens is the experimentation is not very fast. But once you have a computer program, you know, the experimentation is very, very fast, and you can actually play with it. It becomes more like a sport or a game. You know, it has that. You have the joy of abstraction, but also you have the fidelity of reality, real interaction, like live, real time, like you're playing tennis or something like that. So you could interact it in different ways, and you can have a different style of interaction and so on, you know, if I'm making sense, right? So, and now I can subdivide it further, right? So I could do like so something like that, right? So this is possible, right? Okay, so that's okay. What else? So you have that, and then of course you can change the attack and the decay time of the ball. So it's like, reduce the decay time. So now at this point, for better visibility, I'm like, okay, you could say like, I'm sick of Mondrian, let me remove the See, this is the thing. So you just pitch an idea of Mondrian, and then you kind of ditch him, you know, and then like, okay, now let's get very computationally and kind of just have fun, you know, like, so now this is better, right? So yeah. So you can do that, right? Now once you see that the ball is trapped in a box, you want to sort of like, you know, move it away from one box, put it into a different box and so on, right? So for that you could simply just go to tools and move the balls, and you see that? Now that is sort of fine, but sometimes you just want the ball itself to kind of break the wall and go, right? So that can be interesting. So this is the thing with software. So you just keep, once you kind of see something, then you want to keep expanding and so on, right? So now you could like say, okay, so I'm gonna turn this into a record, okay? So I'm going to say made one record. Okay, that's great. So what it's going to do now is whenever it hits a wall or a ceiling, except for the final walls and ceilings, it's going to break through and just keep going, right? So there you go. So and the breaker, you know, the ball is red if it's a record, right? So sometimes if the boxes are too small, it's not going to break, right? So see that? Now it's gone in, right? I can select that. Why not speed it up now, right? I can speed up the ball, right? You see that? So that is possible, right? So now let's say, now this is fine, but then now you feel like, okay, this is, walls are breaking, that's nice, but what if I want to put the walls back together? So you want like a opposite to a wrecker, which is called a healer. So let's create a healer, right? So I'm going to launch a healer. So now what it will do is whenever it passes through a slit, you know, one of these breaks is called a slit, it would basically you know, heal it. All right, so you see that? The interesting property is that once it heals all the slits in a box, it might get trapped in that box. Yeah, so let's get the other ball going as well. Or if you want, you could just manually slit, you know, you could manually like slit it like that, you could do that. You could even make the slit slice really big or small, things like that you can do, right? So all right, so that is all nice. Now what I've deleted all the boxes. That I can even make these balls kind of curve a bit. Yeah, something like that. So this is possible. Now why not make it, or make these, the, you know, like, okay, the boxes we are dividing and so on by hand can't be automated. That's where the automatons are coming in. Okay, already the automatons are active right now, so even, you know, it's still spinning, it's raring to go, it's revving the engines in a way, right? So, and the trail kind of shows you where it's been in the past and so on, and so now we could basically, these are ball operations. We'll come to that next with the box operation. So I could say auto split box every second, pick a random box, split at nodes, and split horizontally and vertically. These are your default setups. So now I could just auto split the box, right, and it starts splitting, right? so that, oops. Okay, so you could like, okay, so I deleted that and then it starts splitting again. All right, I can delete that and start splitting again. All right. So interesting thing is what happens when I say, okay, so I'm not going to split at notes anymore, split anywhere. I don't care, you know, just so it starts splitting. And now if you probably briefly bring back Mondrian, now you'll see that we're kind of, you know, going where Mondrian had been before, right? Boldly go where Mondrian had been before, all right? So we have this thing going on. Now let's just start. Is this music? Well. Alright, so that's anywhere, right? So it's like I can do something like maybe stop this guy for a minute, you know, stop this guy for a minute. I can also do things like I was inspired by the pachinko, right? In the sense, this is now reality, you know, kind of intrudes, but I could do split box horizontally into n boxes. All right, so I can say you know, 8 boxes. Maybe I could do 16 boxes maybe. So let's see, split box horizontally. See, that's like that. See, this guy got trapped. Okay, let's release him. Let's try and release him. All right, so put a manual slit there and gets released. Oh, trapped again. All right, so that sort of thing. I'm just rushing a bit because maybe I have a half an hour more. So this is there, and I want to show you just wait. Okay, so just close that a bit. Now what I'm going to do is go into the ball operations just to show you what it's really. I'm very pleased with the ball operations because by doing the ball operations I also learned how to do noise. You know, that I'll show you later. But so what we'll do is to click on this turn. And you'll see that it starts turning randomly, right? Because it's frozen right now. It's kind of, I'll release that ball. So it has that worm or a ant-like behavior. All I'm doing is randomly turning and I'm interpolating, angular interpolation. So it has this nice smooth ant-like behavior, especially with the pointer, right? So maybe I can increase the trail, so just to so this can be quite so now let's say I call him so he's now a healer, right? Or he could be a bouncer as well, but so I could kind of make split the box, auto split the box, pick a random box. It's been a while since I used Mondrian, so anyway, so pick a random box. No, pick the youngest box. All right, so no, pick the box that has a ball, split anywhere. Now see what will happen is that this scheme will now trap this ball. All right, so you see what happens. Let's see. Yeah, so it's reached the minimum, right? So I've deleted the boxes, but still. It's trapped it there, right? See that? Now again. So this is not artificial intelligence, which is quite hot right now, but it's just basic rules which gives you this emergent property of trapping that ball, right? Because what it does, it auto splits the box, picks a box that has the ball, and then it splits horizontally or vertically, you know, and anywhere. So there's no note restriction. So it will basically go as close to the ball as possible, with the minimum split size being this. So you can reduce that minimum split size, let's say 4, and it would further subdivide it, right? So you can see that. It's kind of really goes close, right? So this sort of thing is possible, right? So. And we could really maybe wait, let me turn that off, right? Turn this. Okay, so I'm going to increase the speed of this guy maybe, and it can be really interesting. So he's moving really fast. All right, he's moving very, very fast. And now let us reduce the every how many seconds. So let's say we reduce that to maybe 0.2 seconds or something. Then it will trap it really, really fast. Okay, that's what we want to see, right? So and we turn this on. All right, so. So I'm deleting and I'm letting go, alright? So right, so this is nice, alright? So I can delete, I can get another attack, right? So because it's randomly generated, the first box, so it arrives at that ball wherever it may be, right? So it arrives at that. So there are various random Mondrian basically, right? So you have this sort of random Mondrian, generative Mondrian, if you will, you know, like, so you have this kind of thing going on, right? So now this ball is a bit trapped. I can move this ball into this box and still the, you know, the splitting operation is happening, right? So I can do this sort of thing, you know. This is fun, right? So it's like, okay, right, so I can paint this thing, right, and then it's kind of right, and then I could maybe turn that ball into a wrecker, right? So I could go in there and say like, okay, toggle wrecker, and there you go, and delete, and then maybe unpause it. So he's going to escape. He's going to escape on his own, right? So he's escaping on his own right now, right? So I can still delete the boxes. So I'm giving a fresh start. You know, so this is the virtual structure and the automatons, you know, and the rules that we have in the structure. We again, like the famous movie Matrix, the iconic, the hackers movie Matrix, says, you know, rules can be bent and others can be broken, and that is quite very true. It's amazing that those filmmakers really are visionary enough that they understood programmers like us, right? You know, this is the whole thing, right? So you create the rules and then you break them, and by breaking them you can sort of see other new rules to put in or something like that. So you just keep on going like this. Life itself is like that, I guess, but some of us, I don't know, maybe we don't see it that way, that's all. Anyway, so that is okay. So I've stopped the split, all right? So I can show you the other operations. So this is speed operation, and that what happens, it really makes it into a anti kind of thing, right? So because you could like make it brake more than accelerate, maybe, I don't know, maybe have a max, it has a max speed, so let's say the brake is more than axle rate. Maybe I'm gonna maybe just increase the axle rate. Maybe the brake is more than axle. Maybe increase the axle rate. Yeah. That is sort of, yeah. So that is like a nice thing. So I can put that. I mean, I can. Come on, bounce. Come on. Yeah. So he's a wrecker. That's why he's just kind of doing that. All right. So he's too tentative because the brake is higher, right, than the axle rate. So if the brake is lower, then he'll move more. Right? So so he's moving more now, right? So manually trapping him, right? This sort of thing. Alright, this is all nice. Okay, now what we want is let's see if we can actually clone this guy. This is going to be really nice, and watch your ears because it can get loud, this one. So what we're going to do is just going to do a clone operation. So this ball gets cloned, and how many clones, how often to clone, how many clones, and then the offset, you want to space it out or not, maybe not, you know, maximum number of balls in the whole system, right? So 64, you can change that. And clone can clone too. Oh my god, that if you click that, you're gonna get into trouble, right? So let's do that then. You know, that's what we're here for, right? So let's do that. All right. So I'm gonna clone it. I just want to prepare myself before I unleash the clones, and hopefully nothing crashes and stuff. Everything looks good. So let's go for clone, right? So I'm gonna clone it, and then clone can clone too, right? But have a clone maybe slowly, right? So maybe every 5 seconds, right? Maybe 3 seconds. Every 3 seconds, clone every 3 seconds. I've still not turned that on, right? So clone can clone too first, and then I basically release the ball. Let's release the ball first. Maybe reduce the speed a bit, reduce the max speed a bit. No. Yeah, keep that max speed right there, and then yeah, we're all set to clone, right? So then yeah, just clone it. That's all. Is it cloning? Oh, there you go. It's cloned, right? So now I can set it up. Like I can maybe make them bounce. Maybe. So all of them are wreckers. That's why all of them are wreckers. All right. I can't stop this thing anymore. They keep on cloning. So I can turn some of them into healers. All right. Let me turn some of them into healers, right? So I can get the boxes back. Maybe reduce the trails, right? So delete some of them. I can delete some of them. I think they're still cloning. Delete some of them. So I'm gonna toggle that into a healer. Alright. So I think Yeah, so you saw the cloning, right? I'm going to maybe clone quickly. This guy, I'll clone first. No, first I'll take them both, right? Ball ops and load the ball. First ball is the wrecker, so I'm going to clone it and clone it every second, right? I'm going to clone it every 2 seconds. All right, so I'm going to clone that. Okay, so that guy's cloned, right? So and I'm gonna select the, okay, so I'm gonna select the, I want to select the healer and clone him as well. Yeah. It's still cloning, it's still cloning. If it's still cloning, new balls will come out, right? They're still cloning. Yeah, you see? Clone no more. Can't clone no more. Reach maximum of 64 balls, right? And they're all like, you know, like rabbits. They're ready to kind of, you know, rabbits don't clone, but just, you know, you get the idea, right? So they're not cloning anymore. That's why. So now you can go in and. Yeah, so that's the thing, right? So that's what, so you see the cloning and all this. These are all virtual operations, but they're all triggering notes and triggering, triggering any pitch. And in Mondrian, at least the volume is fixed. It's like a harpsichord in a way. It's not really like a piano, even though it's percussive. I could code it up in terms of like, okay, maybe if it's vertical axis, it's volume, and so on and so forth. But yeah, that's, you know, that's for the future. But right now there's no volume control, but there's extraordinary pitch control, as you saw, and yeah, these virtual structures and virtual automatons, you know, that's what I refer to as the automatons, to make indiscriminate sound. What I meant by that was not fixed to notes, although I do tend to, you know, revert back to notes if I lose confidence in myself. But there is always, when I'm playing for myself, there is always a space I reach, which is always between the notes. All right, so so when I'm doing a demo, just to be, you know, just to not confuse you and not confuse myself, maybe, you know, like you know, I revert back to the notes. But as you saw, that I can split this particular space at a very fine grained level, right? So this is there. So I'm going to delete this guy, yeah, delete all of this as well. Oh, nice new color. Let's do a health check and see how people are doing, and maybe a health check of the stream, and then we could go further for a few, maybe this, or maybe I've run out of time. I don't know, maybe I have. Maybe if I can get 10 more minutes, then it's possible to sort of wrap it up. Maybe, let's see. I'm gonna just get a new window here and check the stream. Right, so let's see what the stream says. So how many people are sitting up there? Let's take a health check. Who's sitting there? Who's sitting at the stream? Oh my god, there's 6 more people still there. There's 6 people. There's 6 people, right? So okay, so go live, and I'm just gonna do a health check, and like, how do I edit this thing? Was this thing I could actually edit it, and view in the live control room. All right, excellent. So I'm gonna click that, get to the control room, and this is the first time we're doing this sort of lecture thing, so I've not been able to take questions right now, but maybe when I finish, if I get half more hour, maybe, and if you're still having the patience, you could just it's like okay, so all right, so there's 6 viewers, yeah, still here. 7, oh man, maybe that's me. And so okay, so Christopher Parsons definitely has a chip up his sleeve, you know. Okay, yeah, definitely. The school system is all messed up. That's why Corona came to kind of give the school system a whack. All right, I'm just gonna not do too many jokes. Just go very quickly back to Denny. This all looks good. People are still listening. I'll keep going. If they want to stop me, maybe they can stop me, but I think the professor won't do that. He's very kind, and he probably will let me yap a bit more, and then we'll see. All right, so I'm just gonna maybe go for another half more hour. If we want, you can go for a like a drink break, or a nature break or something, So here we are. So I want to show you the waveforms now, and we'll do that. I'm gonna just look at this. Din is out here. This guy is out here. I'm gonna make myself slightly bigger there. Yeah. And what have we got? Oh boy. Oh, my back hurts. Okay. Let's go to the waveforms. Yeah. Let's do the waveforms. All right. Minimize OBS. And then kind of. I showed you all the things I wanted to show. The clone kind of ends it basically with Mondrian. That's where Mondrian is right now, There's also, you could like make slits, and you could actually animate the slits, right? So it's like, let me make a really big slit, right? But there's some sort of bug, I need to fix it, but you could even sort of selection targets, select all the slits, and toggle slit animation will actually make the slits open and close, right? So this is really fun. So it does that. So you could have a ball kind of. You see that slit opens and closes, right? So you see, escape, that sort of thing, right? So it's like that's possible as well. So but that is an experimental kind of feature. It's been there for a while, but I really haven't developed that part of the software. So to be honest, software is like a tree. You can work on different parts of it and develop different parts of it. All right. So I think I've finished Mondrian. I just want to go to my other instrument. This was the original instrument, really, the original DIN instrument, because when I could place continuous sound, like when I could move from one pitch to the other, then it's very suitable. I realized very quickly that it is very suitable for Indian classical music, because I grew up in the culture here in India. So and I kind of know what's going on more or less, you know, not at a virtuosic level, but I kind of know the fundamentals, you know, so that's really not even okay, that's beginner. All right, so I just want to turn this oscilloscope off because the screen real estate is very precious here. Maybe okay. So we have this is called the Microtonal Keyboard. I showed a little bit of this at the performance the other night, and you have as many octaves as you want. So you have this C, and then this right now tuned to a blues scale, so you have this sort of C to C, and then C to C, and then as many octaves as you want. But the interesting thing is that every pixel is a pitch, right? So every pixel is a pitch, right? So you have this thing going on here, and the height is volume. So if I'm there, it's 100%. If I'm here, it's 0, right? So I can do something like I could turn the voice on, and then originally DIN was controlled with the mouse. This is like the ancient DIN, all right? So it's like with the voice, you have just one voice, because once you add the basic waveform, then I could use the mouse to make a theremin kind of thing, and then kind of tie it to Indian classical music. And so I'll turn the delay line also because it gives me a nice backing, you know. Okay, so I'm just going to do some phrases. So something like that. So see how smooth the glissando was, you know, things like that, glissando, vibrato, all these things are possible, right? So you could do all the, you know, what are called in Indian classical tradition, you have the gamaks and the mean and things like that. You can do all that. But once again, you know, the computer just doesn't let you stay in one place, in the sense that it always, the moment you program something, you realize that you could do more, you could do more, you could do more. It keeps on going, right? So So I can improvise while still playing a loop and scratching the loop. I can still improvise. So and then go back into the loop. That's back in the loop because my mouse is here now. It's playing the loop, right? So things like that. So, and then in Indian classical music, you have this concept called the drone, which is like any fixed pitch, right? Drones are not the evil drones we know of recently, but the drone in music is just a fixed pitch and volume. So let's say I put a drone up here exactly on C, right? And then in Indian classical music, maybe let me tune to a Indian classical scale, so you can set up the scales here. So I'm gonna get off the blues thing and get into blues is for, you know, for the Western people, kind of little bit for you know, also African American, black people, white people, and also here in India, blues is also quite well recognized. And then you can change that to an Indian raga if you want. So this sort of thing, right? So it's the defaults, all culturally sensitive. Music becomes a culturally sensitive, almost political thing. We have plenty of examples of that. I mean, I don't need to tell you what they are, like you know them yourself, right? Like, you know, I don't know, things like Pussy Riot or something, the band, you know, that got, you know, thrown into prison or something, you know. You have so many things, like, why am I saying this? I don't even know. Right? Okay. Anyway, excuse me. Right. Okay. So I just want to show you. Let's do a drone there. All right. So I'm going to put a drone there. Drone on the 5th. Drone on the high octave. Maybe reduce the drone master a little bit. I can position it like that if you want. Oh, what did I do? Oops, sorry. Okay. So maybe increase the master after all. Okay, so I can do something like a phrase again if you want. So it's like delay. Something like that, right? Deleted the drums, right? But clearly, you know, I was not going to be an Indian classical musician, go anywhere near Ravi Shankar or somebody like that, right? So it's like, so time to move on, right? So because one of the reasons is that you can place the drone on any pitch, yeah? So that gives you can make drones like this, and now you're no longer in the territory of any sort of music, right? So like that. And then you could, yeah. So you're no longer in any traditional musical system anymore, right? So you could do like. Yeah, so you can do things like that. Now all these virtual structures are all about instrumentation, but what about the timbre? We didn't even touch the timbre, and I just want to very quickly go into the timbral section. And this was from the last night, so the other night when I played the concert. So let me kind of get to a default thing. Now, that's the default one, and I hope you could also like you know, refer to the concert video that's there, so that you can see how many of these things are used, because I can't show you everything, you know, about how it's used, because we don't have time. Like already I'm out of time, I think. So I'm gonna go very quickly here. All right, so this is like one of the interesting things in DIN. It's very unique to DIN is these shapes into waveforms. So you can convert this pointer goes around this 2D shape and it creates this waveform, right? So, and what does that sound like? So let's see. Let's put a drone in there. So let's put a drone like this. Maybe make it vibrate a bit. The automation I talked about, right? The automation right there. So I can make it go in that axis, change the volume, make it go in this axis, change the pitch, make the pointers, the arrow pointers, they open another Pandora box, right? So it's like it just keeps on going. So let me forget about the arrows for now, right? So we're just gonna have those are the drones, right? So now let's go to the waveform, and here you can change the paint harmonics, remove that maybe. So that's your basic sine wave, right? That's your basic sine wave. You see what it does, right? And if you didn't make the shape form, then you have this is basically the sine wave. And you have a sine wave which is an approximation, right? This is an approximation of the sine wave, and you see how close it sounds to the sine wave, but it's made of Bezier curves, so you could like edit it. So it's no longer, it's now Bezier curves, right? And you can see the proof here. The harmonics change when it's just a sine wave. It's a single harmonic, but when the moment you sculpt it, so the Bezier curve can be used to produce sine wave form very close, as I told you earlier. Something like that, right? So now let's do this sort of thing. Yeah, and then so right now only the pitch is changing and all the volumes are kind of as they were when they were created. You can change the volume as well. So this is what I call visual drone modulation, because it's not happening at the sample level, it's happening once per buffer, because to do it at the sample level will be so tough with current computer, or at least my programming capability. But the voice modulation is sample level modulation, so there is Bezier on the modulator and the Bezier on the carrier, so you could have things like, could have very interesting effects. But oops, sorry, well, sorry about that. We could just so I could do voice and FM depth. So here is sample level modulation. And then you could change the timbre of this, right, by editing the Bezier curve, and that can create really nice sound, right? Waveform, right? And then you could go there and something like that, right? So changing the BPM. Something like that, right? So, and it all used this Bezier, sorry, this Bezier curve for the waveform. All right. So then you could do. Let me show you two last elements of geometry, and then I'm going to finish. All right. So I'm just gonna do this thing called the drone pendulum, and this is based on the wave pendulum. I have this video of the wave pendulum. Let me show you that. Right. So let's see if I can bring that up. Okay, so that's basically showing that, and I'm in the corner, but you can't see it. That's fine. That's fine, right? So what I'm going to do is just play this video for you, and yeah, let's just play this, right? So is it playing? Yeah, it's playing now, I think. So here what's happening is that pay attention to the length of each of the pendulum. The length controls how often the pendulum oscillates back and forth, right? So what is called the period, it controls the period of oscillation. So what he's going to do is he's going to stretch it out. He's going to stretch it out to some depth, you know, and then let it go, right? So and then it just, because they are all now oscillating at a slightly different BPM, all right? So that is why it creates these wonderful patterns, right? So you'll see that it creates patterns, and also because it's natural, driven by gravity, there's very subtle changes in its oscillation period as well. I think you know, there's some variation. There's damping, for example. The depth changes, you know, over time. So it creates lots of patterns. I've tried to simulate that, but I don't have I haven't included the random variations yet. That could be a really interesting extension. So I'm going to show you that I've done this. I've been inspired by this, and I've done you know, what I call the drone pendulum, which is going to be a bunch of drones. You can see where it's going now, right? So each of these bulbs or table tennis balls is basically a drone, right? And the depth of vibration is your AM depth, and the BPM is going to be equivalent to your length, because there's nothing called the length in the virtual space. So anyway, this video is finished. So that's very sweet video. It's got 7 million, 10 million views. My God. All right, so I'm going to close that browser, because that's all I've got to show you on the video front. Oh, you're still here, man. Oh, you're still here. Gee, I'm looking at myself. 10 minutes, stop. Water. So, let's see, where are we? Okay, so the drone pendulum, right? So I'm gonna get into the drone pendulum. So what the drone pendulum is, right? Okay, so I push the Microtonal keyboard up, turn the voice off, turn the delay off. We don't need those guys anymore. And so this is yet another virtual engine, virtual structure, virtual automaton, you know. So the create drone pendulum orientation is horizontal, which means that it's going to vibrate up and down, yeah, but it's oriented horizontally. So the spacing in between the drones and the initial BPM, all right. So that's not it's, some of these things are better to just do it, all right. So just click on this create pendulum, right, and I can choose a point. Click and drag a box to make a drone pendulum. So you just do, let's say I do click there, and let's say I click there. All right, so just gonna let it go. Oops! Oh, that's because from last night's setup I didn't change the. Right, we come here, and this guy overlay is off. Let's put it. I'll explain to you what I mean by this, but. Move this guy up here, right? Go back to the main window, and now I'm gonna do that. So everything in DIN is Bezier curves, right? Whenever you see any sort of vector kind of line editing anything, it's all Bezier curves, which gives you maximum flexibility for sculpting everything from envelope to modulators to waveforms, as you saw, you know. But it's got not just Bezier curves, so there are other things going on in DIN, especially I'll show you, come back to it in a minute, but this one first. Alright, so I'm gonna create. Very nice, you see? So it's kind of started very quickly, right? So let's put some trail on. Don't know what your sound is like. Let's increase the sound. Very nice. Maybe reduce the trail a bit, right? Yeah, you see that? You see that? Because there's no natural sort of variation or damping. These things can be added maybe in the future releases, yeah. But so it just vibrates like that. All right. So it's you could call it. You could call it an engine. You know, virtual structure, virtual automaton, a dynamic structure, a tensor gritty. You know, I don't know, anything. You know, so modulation. Let's say I do FM depth. See, the interesting thing is, it's still using the same parameters, right? So I could FM depth it. Yeah, so I could do that. Bring it back. Bring it back. Now, you know, you could do what you could do in software is, this is what is fun, right? This is what is software, right? So you could then pick that and change how the amplitude behaves, right? So I could do like, I could maybe bring this guy down. So there's no amplitude anymore, very little amplitude, right? So I could bring that guy down, flatten it, no amplitude. Make him vibrate like that, right? All real time, right? So looks complicated, but I assure you, you'll pick it up if you want to. So you could do like that, example, right? So then kind of, you know, so the right hand section is pretty much, the volume is, there's no amplitude depth. This basically is depth. This is depth. So the depth for the pendulums on the right, I mean for the drones on the right, is very low, like very low, but this depth is quite high. So you can like, you can do this sort of thing, you know? Yeah, see that? You could keep sculpting this, all right? And then let's add some visual effects. So I have this sort of thing. I could connect it like this, yeah? Give you some idea what's going on. It's quite cosmetic. It doesn't really. I could disconnect it. Same thing. I could maybe connect it in different kinds of steps. You know, this is all very Houdini-like. So this is 2 steps. Disconnected, don't like it. Maybe 5 steps, connected, much nicer. This has this sort of, it kind of gives this pseudo 3D kind of look. You see that? Yeah. Disconnect that. Yeah. So, and then I can go to the drone waveform, and this is the drone waveform, and I can let's say do a harmonic kind of thing here like this, and then auto apply that. Yeah. Something like that. Maybe. Yeah, do something like that. All right, so I'm gonna close that a bit. Right. So what else can I show you? Oh yeah, the worm thing is the latest thing. So for this, what I do is typically I want a bunch of drones which have no depth, no, like if I turn the depth to 0, right, this all seems a bit hard to understand or something. Somebody said it's all very confusing, but it can be, but but if you watch my videos, I think you'll get there. Maybe I can do some workshops. Like now that this streaming system is working, I can do some workshops. Okay, anyhow, let's keep going with this right now. I'm going to take a few more minutes, and I would suggest you also look at my concert video the other night, because I've shown some things there. So I'm going to keep the drones there, right? So now they're all flat, there's no vibration, right? I can move them, right? So I can move them, then I can connect them, right? So let's say I connect with just one step, so I can then show the velocity vector, then I can do this is again another virtual structure, all right? Scheme, you could say, a scheme inspired by articulated structures, bones and things like that. This is all from computer graphics and animation. It's quite obvious, or gaming. But now the power of having drones in any pitch comes, because now you could have, like, you're having this sort of soundscapes. This sort of thing, right? And then you could, like, what is this thing called? This rectangle here. This is the number of tones between C and D flat, right? So we can expand that, right? Why not? So what happens? See that? Right? We can expand that. Maybe select this and we can move this. Okay, select this, move this. Why not? It's a virtual thing. It says now, like, every pixel is a pitch and a volume, right? And it's all accurately transferred to sound. That's one of the strengths of DIN. And you could, you see the pitch values, they're so close to each other, right? Raise the volume a bit. That's your notes, right? Like that. You can disconnect it if you want. Let's say I disconnect that, and then I can connect just that, and then move this. like that. Yeah. This guy is pointing to that disconnected guy. He's like, it's like a lizard. It's like a lizard. So you disconnect the guy, you just broken the tail off of a lizard. So it's just pointing to this drone here. This one here. Anyway. So this is a possibility, right? Maybe, I don't know, that's pretty much it. What else is there? Yeah, you could also animate these guys, right? So I could do like, I think the professor is gonna be like a little bit, Jag, hurry up. And I can hear him now, which is fine. I understand. It's like 2 hours almost, I guess. So what I'm gonna do is just forgot what I was gonna do. Okay, I can modulate the drones, right? So I can let me do that, for example. Okay. Let's get the, yeah, there's nice timbre there. Maybe some higher harmonics. Yeah, so you could select this range, right? And then I can modulate that range. So I could reduce the width, for example. So it's like an accordion, yeah? Okay, so now I can, let's say I snap the drones. Can maybe change the octave. So that sort of thing. So you could like be dynamically changing that, and all the drones, the pitches will change and so on. So I don't know how much time I've got, so I'll just try to close it. But maybe just one more kind of thing I can show you with noise, all right? Which is the noise that I showed you in Mondrian about the ball turning and, you know, the ball operations, the noise in ball operations. I can sort of use it here as well. So I have this sort of, maybe I can kind of push this back up a little bit. Once again, I fall back to linear, not because, you know, it's much more fun with Beziers, but just to keep it simple. Sometimes the default settings are linear. And let's say I create a drone pendulum like this. Maybe I'll have a smaller drone pendulum, alright? So just gonna maybe increase the spacing a bit. So I'll have a smaller drone pendulum for the same sort of width. You can now see what's going on. So yeah, now I can drone to noise. So I can just, you know, this is like noise at a particular pitch. That kind of sounds weird, but it kind of I can tell you another time how it works. But noise dialed to a pitch, so it proportional to the pitch, right? So whatever pitch it. So let's say I increase the octave here. You know, so I do, yeah. So So some of these, so you see that some of these pitches are in the 2000 Hertz range, so there's high frequency noise. And then depending upon the other pitches, right, so 65 here, so let's say I select this and maybe make it bigger, they're all going down, right? So it's proportional to pitch, all right? So once again, you could animate this. And automate that if you want. So modulate it with maybe increase the width. Maybe BPM, increase the BPM. So yeah, and then unfreeze the drones. Right, so I'm gonna and then you have the noise interpolator. This goes on and on. This is not a nice default. This is a better default. Yeah. How the noise sample interpolates. Alright, so. Yeah, see that? That's because of the drone pendulum. Syncing, converging. So scale it. Then I convert it back to drone. Snap it. Unsnap. Convert back to noise. Alright, then that's enough. That's enough. So yeah, I tried to show you as much as possible, but it's 14 years of work, and not trying to be cool about that, but it's a lot of work, right? It's many years. So, and thank you for watching, really. And yeah, so 2 hours, I think I'm half hour over, but anyhow, it was a lot of fun doing this, and hopefully this will be a way to communicate with you guys in the future, maybe take questions in the future and so on. So if you have any final questions, then maybe I can come back onto the stream and take some questions from the chat if you have the energy for it. I seem to have very small amount of energy for that, so I'm gonna try and squeeze that in, right? So let's see. Bring up OBS, make myself bigger. Ooh, I'm still alive. Thank you guys for watching, and yeah, let's get to the browser. The control room. Okay, who's here? 4 users still here. Oh my god, 4 users are still here. So let's see, I'm gonna sort of reduce my so let's see, I'm gonna sort of reduce my so let's see, I'm gonna sort of reduce my so let's see, I'm gonna sort of reduce my so let's see. Okay, so yeah, so the question is to check your amazing program. Oh, thank you, kind of you, but installed. Okay, you need to get a proper graphics card, and graphics card is the main thing, because all of DIN's visual is OpenGL. So most of the integrated graphics cards have OpenGL, so you should be fine if you have a recent enough laptop. But if you have a really old laptop, then oh, you have no sound from DIN. I'm so sorry, I can't help you just with that particular setup of Linux that you've got going, you know, because it's a bit complicated. But rest assured that DIN has been tested very, very, very thoroughly over the years. So I would think it's most likely a sound problem. You can hear it from the web browser. You need to close the web browser. Only DIN must be operational. Then you should possibly get some sound from DIN. Or you go to the settings screen and there will be the sound setup, and you can sort of change the sound card or something. This is very hard to support, really. In Linux, you're better off asking in the forum, you know, like I don't know how to say this, because if you it should work out of the box. That's the idea, really. You have to believe me. There are many other Linux people have installed DIN, so should work. I really wouldn't know without. If I was not next to you, it would be hard to point out why it's not working, because Linux is like that, you understand? So it's like, yeah, if you try other programs and they are working, making sounds, maybe if you follow if you're building from the source code, are you using the evaluation? This is the question. So if you're building from source code, if you're able to absolutely build it correctly, then it should work. It should work in the sense, the reason I'm saying is that it's very well tested by many people. Many people have written to me like you've done. So it should work. If you could persist with it a little bit, just try to see if your sound setup is fine, and then if you're building from source, then you know, so should be all right. Yeah. Any more questions? I think maybe there's nobody. Yeah. So I'll call it a night, and thank you for watching and listening, and see you on the next one. You know? So that's all good. Cheers. Thanks, Professor. Thank you. Peace. So you're trying the evaluation. All right. Okay. So yeah, well, try to build it from the source code. If you're using Linux, you should build it from the source code. Otherwise, just if your system is not a Linux system, if you're trying the evaluation, then why not just download the evaluation on Windows or Mac and just try it there, you know, because you're still trying the evaluation on Linux. The point of being on Linux is if you could build it from the source code, because you can even see my source code and understand what's going on and even change it. But if you're just using the evaluation, then why Linux? Just try to do it on Windows or Mac. You know? So yeah, all right then. Good night. Yeah, thank you all, and yeah, nice talking to you. Cheers.